In 4.1, we're going to be discussing factors and prime factorization. A prime number is a whole number that is greater than 1. It has exactly two factors, 1 and itself. A composite number is a whole number greater than 1, but it has more than two factors. Factors are numbers that go into another number evenly. You're dividing in order to figure out the factors. A multiple of a number is the product of a number and any other non-zero number. In order to find a multiple, you are multiplying. If we were to list the multiples of 2, you have to multiply 2 by another non-zero whole number. So when I multiply 2 times 1, I get 2. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8, and so on. You keep multiplying by the next whole number to find the next multiple. In this chart, what I would like for you to do following the directions is to start with the number 2 and circle it. You're then going to cross out every multiple of 2 after that point. So using the list that we just created, the next multiple of 2 is 4, then 6, then 8. And we're going to keep on going. I would like for you to continue to cross out the multiples of 2. When you're done with that, you're then going to move on to the next number that's not crossed out. And in this chart, it's going to be the number 3. You're then going to cross out the multiples of 3. Keep going, circling the next number and crossing out the rest of its multiples. When you're done with that, I would like for you to answer question number 1 here. With examples of prime and composite numbers in this chart, let's take a look at number 24. And I tell you that the factors of number 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Because this number has more than two factors, that makes this number a composite number. Press pause on the video, and you're going to fill out the rest of this chart, identifying each of the numbers to the left as either prime or composite. When you're done completing the chart, press play to continue with the rest of the lesson. In example 1, we're going to be writing the factors. We have to identify the factors of the number. In other words, we're going to think, what numbers are these divisible by? 30. 30 is divisible by 1. Every number is divisible by 1, so that is the starting point. Is 30 divisible by 2? It's divisible by 3. It's divisible by 5, 6, 10, 15, and 30. And what you might notice about these factors is that they match up. In other words, when you multiply them together, they are the number that we're looking at. So if I start with my number all the way to the left, and I multiply it with the number all the way to the right, 1 times 30 is 30. Then I match up the next two. 2 times 15 is 30. 3 times 10 is 30. And 5 times 6 is 30. When we move on to the next example of 31, 31 is a prime number. It only has two factors, 1 and itself. 45 has a factor of 1, it has a factor of 3, it has a factor of 5, 9, 15, and 45. And again, when we match them up, 1 times 45 is 45, 3 times 15 is 45, and 5 times 9 is 45. When we're finding the prime factorization, you are writing the number as a product of its prime numbers. You can use a diagram called a factor tree to write the prime factorization of a number. When we are starting with the number 630, you have to write the prime factorization of it. Think of two factors that go into 630, that when you multiply them together, they equal 630. and you're going to branch it off. And I know 630 is divisible by 10 because it ends in a 0. And I would multiply that 10 times 63. And now I'm going to branch off of each one of them. What numbers, when multiplied together, give me 10, 2, and 5? And what numbers, when I multiply them together, give me 63, 7 times 9? So if I were to multiply this row, 2 times 5 times 7 times 9, it's going to bring me back to our original number of 630. Let's continue to branch off of each section. 2 is a prime number. It cannot be broken down anymore. 5 is also a prime number, so I cannot branch off of that anymore. 7 is a prime number. However, 9 can be broken down to 3 times 3. So what we have now ended our factor tree with is a bottom row of numbers that are all prime. There can be more than one way to do a factor tree. 630 can also be divisible by 30 and 21. When I multiply those two numbers together, I also get 630. If I wanted to branch 30 off, I get 6 times 5, and 21 would be 3 times 7. 6 can still be broken down to 2 times 3. 5 is prime, 3 is prime, 7 is prime. When I look at both of these rows, no matter which way I took to get to the end, I end up with the same prime numbers. Now it's taking them and listing them. When you're writing your prime numbers, you always want to start with your smallest prime number and list them from biggest to largest. So I'm going to start with my 2. And then I'm going to show that I'm multiplying that by 3. But because I have 2 3s, I need to write both of them. Then I move on to my 5 times 7. If I look at my factor tree to the right, I have the same prime numbers. I have 2, I have 3, I have 5, and I have 7. But we're not done here, because when you're writing prime factorization, you want to write it using exponents. So my final prime factorization is 2 times 3 squared times 5 times 7. For this checkpoint, press pause. I want you to create 2 factor trees for these two numbers, 83, 180. Find the prime factorization. Remember, you list your factors from smallest to largest, and you use exponents if you have more than one of the same factor. The last part of this lesson deals with finding or factoring monomials. A monomial is a number, variable, or the product of a number and one or more variables with powers. Notice I bolded the word product. That's because it's shown with multiplication. In this chart, I show you the difference between a monomial and a non-monomial. 7x is a monomial. It has a number, it's a variable, and it's the product of them. 7 plus x is not a monomial. That's showing the sum, not a product. 25m times n squared deals with multiplication. 25m minus n squared is not. To factor out the monomial 28 times x times y squared, you're going to factor out that 28 like you would in a factor tree. 28 can be broken down into 4 times 7. The 4 can be broken down to 2 times 2, and since the 7 is prime, I can't break that down anymore. But I still have these variables, and I need to remember to include them in my factoring. How do I include them in my final factoring is I bring down my x. That's still showing 7 times x. But the way I want to show y cubed, or y to the third power, is the same as y times y times y. So if I'm factoring the monomial 28xy cubed, that is 2 times 2 times 7 times x times y times y times y. And at this checkpoint, please factor out these monomials for 1, 2, and 3, and we will go over them tomorrow in class.